A particle moves along a horizontal line where its velocity is given by the function below. So there you have it. Find the distance and the displacement over the interval. All right, let's understand the difference between the two. All right, displacement is the idea that we start somewhere, and let's just say I take 5 steps forward, I take 8 steps backwards. My displacement has me at -3 steps. What does that even mean? That means from where I started to where I'm finished, I am 3 steps backwards. Now, if I were to look at the same exact problem, the same exact scenario as far as distance goes, where I take 5 steps forward and 8 steps back, I don't care about like a negative position. I'm taking 13 total steps. So what we're going to do is we are going to find displacement. We're going to find distance. One's going to tell us where we are currently at the moment, and the other one's going to tell us where or how many spaces, units, whatever that we moved. So let's start with the easier one first. Let's start with displacement. Okay. Displacement is pretty simple, relatively speaking. You take the integral from where you start to where you finish of your velocity function, and that's pretty much it. Okay, nothing fancy, nothing crazy. That is the displacement. So my velocity function was 3t squared minus 22t, close that, dt. The derivative, the integral of 3t squared is t cubed minus 22t, the integral of that is 11t squared, and my limits of integration are 0 and 10. Fundamental theorem of calculus says that we write this guy out, plug in 10, so we have 10 cubed, which is 1,000, a k, if you will, and 11 times 100, which is 1,100, minus, notice I didn't write it out, plug in 0 cubed, get nothing. Plug in 0 squared, get nothing. So nothing. So we end up with negative 100, whatever. What are we talking about? Units? Nothing. It doesn't say. So we'll say that our displacement is 100 units backwards. So this is not too different from any other regular problem so far that we're used to seeing. That changes though, because if you're trying to find the distance, you don't care where you end up. You care what you've done in the positives and in the negatives. So what we do here is we set up an integral between 0 to 10 of the absolute value of our vertical or our velocity function. Okay, so that requires us doing a few things. Noticing I'm writing small because this takes a little bit of space for me. All right, so the first thing I have to do is I have to find kind of what's critical points. If I'm going to be going forwards, that tells me a distance of something. And if I'm going backwards, that tells me a distance of something too. So what I kind of need to do is find out when I'm going forward and when I'm going backwards. And the way I can find that is I find out when velocity is increasing and when velocity is decreasing. So here's my velocity function. Let's set it equal to 0 a la critical points. A la critical points. Let's factor out a t. So now we have t times 3t minus 22. According to the zero product property, t is 0. So that's one of my times. So right at the very beginning. So that makes life kind of easy. If I add 22 and divide by 3, that gives me 22 over 3 for where things change. Okay, so I'm going to create kind of like a sign chart. 22 over 3 is where the magic happens. I'm going to plug in, normally I would plug in 0, but I can't plug in 0 because technically that's a critical point. So if I plug in 1 and find out if this gives me positive or negative, that'll help. And if I plug in 10, I can actually do 10. That'll help me determine if it's increasing or decreasing. So Plugging in 1 and doing some mental math, I get 3 times 1 squared minus 22 times 1 gives me a negative number. So I'm decreasing here. So between 0 seconds and 22 over 3, that's supposed to say 3. I don't know why that looked like 13. Between 0 and 22 over 3, I have, or I'm going backwards because my velocity is negative. Can I erase that little one-looking thing? I'm scared. Let's go. Where? Come on. Go away. Yeah. All right. Now let's see what happens when I plug in 10, because I'm allowed to plug in 10. See what kind of number I get. 300 minus 220, positive, increasing. All right. Let's cut this down a little bit more. So in my negative section, all right, I'm going to set up an integral where I'm negative from 0 to 22 over 3, so 0 to 22 over 3 of negative VT. So by throwing a negative in front of this formula, I am allowing myself to kind of say, all right, well, I'm going to get a negative distance, but by negativing, a negative, it becomes positive. So that'll be helpful. My other inequality, which shouldn't take up too much space, is going to be from 22 thirds to 10 of regular velocity. Nothing fancy about that, dt. All right? So I'm going to have the integral between 0 and 22 over 3. Let's throw the negative out here. Of Vt is 3t squared minus 22t dt. I already know what's going to happen. I'm going to end up with this guy, so I have t negative t cubed plus 11t squared between 22 over 3 and 0. So when I do the math here, when I do, the fundamental theorem of calculus, I get negative 22 thirds cubed, whatever that is, plus 11 times 22 thirds squared, minus zeros. So 22 over 3 cubed.
It's approximately 0.
That's not at all what I wanted. What's 22 divided by 3?
It's approximately 7.333.
What's 7.333 cubed?
It's approximately 394.3165.
394.316. So we'll put 32 plus. What's 22 over 3?
It's approximately 7.
What's 7.333 squared?
It's approximately 53.77.
What's 53.772889 to the times 11?
It's approximately 591.5017.
Okay, that actually did work. So 59.1. 591.5 minus 314.32.
It's 277.18.
Okay. Lots of calculating there. This guy is going to be slightly more challenging. Let's get a fun color. As you can see, the fun color is popped off to the side. Let's get a nice little orange in there. All right, so we already know what happens when I take the integral of Vt because that happened over here. So I have t to the third minus 11t squared. Limits are 10 and 22 over 3. All right, so the nice thing about this guy right here is I know what's going to happen because I plugged 10 in over here and got negative 100. Now, when I plugged in negative 200, or when I plugged in, what was it, 22 over 3 into the negative form of this, I got positive that. So I would get minus 277.18 for this one, which is a double negative becomes a positive 177.18. So my final distance traveled is found by me taking u and adding them together, 177.18 plus 277.18.
It's 454.36.
And that's your guy. And that's distance and displacement. So on a fun scale, I'd say it's about an 11 out of 10. On a difficulty scale, same. But it's not work if you're having a great time. Am I right? Like and subscribe. Thanks for watching.